Alright, so we're going to talk about strings tonight. And we've been doing a lot of work in strings already, but we're just going to get a little more into it formally. So everyone should already know what a string is. It's text output. It's sort of a universal data type that can hold any character in it. So we'll look at the string, and we're going to look at the string as a class and an object. We've been using strings, but we've been using them like a primitive type, and the string is sort of a special class. That is a class, but allows you to use it as a primitive type as well. That's unusual. But we'll talk about the different constructors for strings. We're going to talk about a string as being something called immutable. Immutable means that you can't change the value. You can't change the string itself. You can change the value. You can't change the string itself. And we also talked about something called an intern string, and what we mean by an intern string. It really has some more to do with efficiency and compilation than anything else, to use less memory. Comparing strings, we probably did that a little bit already. The length property of it, how to get substrings or a portion of a string, converting values in strings, doing various types of matches and searches on it, converting from string to an array, and converting characters and numbers in a string, looking at format information, and we have a couple of examples that we'll look at as well. So you probably already know, basic things about a string. We did this on our first lab when we did a Hello World and Welcome to Java. It's just any sort of text between double quotes. We are going to look at, in more depth in strings, the different methods it has, and converting it to and from various types, which very often data is temporarily put into a string and then converted to another type because string is universal and other types aren't. So there's a couple of ways of doing it. We learned how to create strings just by saying string, my string equals hello. You can actually use the actual constructor of a string to construct it. So just like you can any other object, like bicycle, you can do that as well. And you can pass in a string variable or a string literal. And you can also do it this way. This is the way we've been doing it so far, for the most part, and that works as well. The string is the only object that works for, by the way. All right. You can do it on multiple lines. I think in the bicycle class we actually are doing that. Lab 3. If we look at this lab here, part of it is we wanted to do it on multiple lines right here, which says create two strings, and then bicycle 1 is owned by Kenny. Use full name and license number for bicycle 1. So stored in the string below, or above rather. So here we could say name 1 is equal to like that. So this is creating the reference on one line and then initializing, giving it a value on a second line. So, which is kind of important because that's what the lab called for. As far as tracing the code goes, you can give, this is giving it an initial value and then changing it to something else. Right, so initially is HTML and then we change it to Java. Interned strings. So now this is an interesting topic. Since strings are immutable, which means they can't be changed, and are frequently used to improve efficiency and save memory, Java uses a unique instance for string literals with the same character sequence. Such an instance is called intern. Okay? Intern basically means is that if you've got a bunch of strings, you create 10 strings and all 10 of them says hello world exactly, and they match in case and everything. Instead of Java taking a memory for hello world 10 times, it actually will only create the text hello world in memory in one location, and will have all 10 strings actually pointing to that same place in memory. So it's more efficient. That's what we mean by interned string. So in this particular case, and this only happens when you use the shortcut method. But when you use the full object-oriented way, then actually Java doesn't do that. It actually creates a new memory location. So if we say string S1 equals welcome to Java, and string S2 equals new string welcome to Java, and then string S3 is equal to welcome to Java, then S1 and S3 actually point to the same memory location, an interned version of the string. Whereas S2, because it was created as a proper object, it actually gets a different memory location. So this is a way of just making memory more efficient. Because very often you'll have things like that happen. There are other ways, as we get into it, a little more advanced of doing that. And we'll show you. Also, when we say something is equal or not, in the case of an object, when we say is it equal, what we're really saying is, are they the same object? So in the case of S1 and S2, that's a typo there, I should say S2, it's false, because although they have the same value, they are not the same object. Whereas S1 and S3 are the same object because they're pointing to the same exact location in memory. So the first print line would print out false, and the second would print out true. Okay, we can maybe just look at a couple of these things here. And again, we'll see that S1 is not equal to S2 because they're different objects. But S1 and S3 are the same object, so it comes out true. Okay, so again, S1, the text working to Java doesn't yet exist, so it creates that in memory. The second string is created as a proper object, so it automatically gets its own place in memory. And the third one is created using the shortcut primitive method, and because welcome to Java already exists, it actually goes and points to the original version. Okay, so now we're on some string conversion comparisons. So we said before, that this one here came out false because they're not the same object. Even though they have the same value, they're different objects in memory. It's really just saying, are they the same thing in memory? However, if we go and we try and use a method that says dot equals, this method here is actually going to look at the value. The equals method looks at the value. And I should have done that differently. Maybe differently. And again, this should be equals as well. Now if we run this, we'll see that S1 equals, and I should probably change this to be, say, equals, or the values equal each other. Right, so the equal sign by itself says, are they the same object? The equals method says, do they have the same value? There's others as well. You can take comparisons on case, for example. We could now go back and I could say, make that a lowercase. Right, so now if I go and I do this, we're again going to see that S1 and S2 are not equal to each other because the J is now lowercase. So that's why it no longer equals it. However, if I go and say dot equals ignore case, then it comes back as true, because this one basically ignores the case. The normal dot equals method cares about the case. It doesn't ignore it. Compare to gives you a couple of different strings. It returns an integer, and the integer it returns really is whether something is larger or smaller, and it will return a numeric value. So one of the things we could easily do here is say then maybe let's go back and make that a J again. Dot compare to. Now, if they're equal in value, it'll return 0. But if one is less than the other, so I'll show you the different possibilities. So here, maybe I'll compare it, instead of welcome to Java, I'll compare it to hello world, which, and then, see what happens. So now here you see that the 2 at the end, when we do the comparison, I should say compare. When you compare them, again, you're comparing values, it comes to 0 because there's no difference. In the case of comparing it to hello world, you're getting a positive value of 15. And that means that, basically, I think what that would mean is that welcome to Java is 15 characters larger than hello, and it's really looking at the first character. So, if we were to count from H to W, that should be 15 characters. So, do it the other way. I'll compare it to next W, X, Y, Z. Let's just compare it and call it to zebra. So now it should come less than it by a couple of characters. And it does, -3. So that's the number of characters difference. So Z is 3 characters more than W. So you get the comparison. Now, normally it looks at it character by character. So if the first character is different, then it doesn't bother with any of the other characters. It just figures out what's the difference between them. And you've got some others as well. You can do matches of regions, which gets more different, and there's pattern matching, and whether it starts with something or ends with something. So you've got a couple of different options here. So I think we already did some simple examples here to show you. Compare to, we already looked at that. And you can use it in an if statement, of course. And I think you had, well, that was numeric, but yeah. So you can compare two things, and to see which is greater than, you can obviously use them in an if statement. Length, char-at are really good methods, commonly used. Use them all the time. I use them all the time, especially char-at. And a concat's useful too, but you can also just use the plus sign. So, I mean, one of the things you could do is you could say, s1.length. And it's nice when you hit that dot, it gives, NetBeans gives you everything. You could say something like if. You can do it this way. You can do this as well, by the way. Zebra dot char at 0 is equal to character Z, then system dot out and find end of the alphabet. Something like that, for example. So a number of different things you can do. Turn 7. Character at. So each one of these is an index. Remember, a string is really an array of characters deep down inside. So, and it's 0 based. So the first letter will be char at 0. The second letter will be char at 1, char at 2, and so forth. And the length is 15. So 0 to 14, it's like an array. In fact, a string really is an array. I didn't even say it's like an array, it is an array. Any questions so far? Okay. So we've been doing the S1S plus 2 already. You can also use the concat method. Not too many people use the concat method because it's easier just to use the plus sign. I don't think there's any advantage to using it.